Welcome. This question here says an 80 kilogram mass is located at the origin. Determine the potential energy of a 5 kilogram mass when it is located at 0I plus 2J plus 0K meters. So let's visualize. Here's my 80 kilogram mass. And then this is none in the X, 2 in the Y, 0 in the K. So this is 5 kilograms, and the, if you like, the vector going from there to there is 0I plus 2J plus 0K meters. This is not a question that's going to involve manipulating IJK vectors apart from visualization. This basically just tells me how far the 5 kilogram mass is away from the 80 kilogram mass. The actual direction is not important. It's more detailed if I give you an IJK rather than just a separation. I need to find a relationship that determines what to do. I try to learn as few equations as possible, and I remember that my difference in potential energy between 2 points was equal to minus G M1 M2 times 1 over R final minus 1 over R initial. I don't have a final and initial. Well, I do have a final position. This is where I want to end up because this is where I want my answer from. But I'm not given an initial position, and I'm not asked for the potential energy difference. But if I use the logic that my potential energy of a mass at a given point in a gravitational field is equal to the amount of work done in bringing that point to that position, that mass, to that position from infinitely far away, then I can say, oh, this would be minus G M1 M2 1 over RF minus 1 over, and initially I was infinitely far away. Well, 1 over infinity is 0, and so this simplifies actually to minus G M1 M2 over R final. And many people just from practice know this equation, but if you don't recall it, you can get it by visualizing how you work the physics of it. So UG is equal to minus G. M1 of course is in this case 80, M2 of course is in this case 5, and the separation between the two is simply 2. So this would be 80 times 5 is 40, and I'm sorry, it's 400, and 400 divided by 2 is 200. And as I look to the top, I see that I don't have the answer there at all. So it would be minus 200 big G joules would be my answer. And that would simplify to something like 13.5 times 10 to the minus 9 joules for a total numeric value. And as soon as I go off the video, I'll change these for my notes. So there we have it.